What you're seeing is a small ray of hope for supersonic flight, National Aeronautics and Space Administration's new X-59 plane. Look, in the year 2003, the Concorde retired, and since then, there has been no supersonic passenger plane. Several projects have emerged, but over the years, these have been canceled. Over 20 years have passed, and there's no supersonic passenger plane project. Do you recognize this plane? The Soviet Concorde, look closely, it has the United States flag on the tail. We'll talk about this later. In this video, I tell you why it's so easy for supersonic passenger plane projects to fail, and why National Aeronautics and Space Administration could change everything. And now we are going to talk about the supersonic plane, which is going to change absolutely everything. World War I. They later realized they could transport dozens of people, significantly reducing transport times. Then came the jet planes, which allowed to fly much faster and higher than propeller planes. And this would reduce costs. A couple of years later, an experimental plane exceeded the speed of sound, so that idea was also adapted to passenger planes. Well, to carry out this idea, several projects led by world powers emerged. The Soviet Union designed the Tupolev Tu-144. Great Britain and France teamed up to jointly design the Concorde. On the other hand, the United States would be responsible for designing the Boeing 2707. These three projects ended up being resounding failures, though to varying degrees. For example, the Boeing 2707 was never manufactured. The Soviet Tupolev Tu-144 only made 50 passenger flights and was cancelled 7 years after making its first flight. It's curious because National Aeronautics and Space Administration 15 years later asked them for the plane to conduct research on supersonic passenger flight. That's why this Tupolev 144 model has the United States flag. And it was the American agency itself that was the last to fly that plane. Meanwhile, the Concorde kept flying, albeit unprofitably, solely with the backing of the British and French governments. Until 2003 when it was retired. Supersonic flight has several problems compared to subsonic flight, and to understand the difficulty of all these planes, we need to pay them a lot of attention. The physics differ significantly between subsonic and supersonic wings due to changes in air behavior. This channel has multiple videos on this topic, so I won't go into much detail here. But when an object moves, it pushes aside the air particles in front of it. This happens because as it advances, it generates pressure waves that push the particles aside. If we were to see a computer analysis representing the pressure, we would see that there is a part in front of the object where the pressure is increasing a lot, and that is what pushes any particle out of the object's path. We can see this with our own eyes, for example, in a wind tunnel, where we use smoke to see the flow. We can see that the smoke never actually hits the object, it moves away before that happens. This only occurs in subsonic flow. It changes when the object moves faster than the speed of sound. The air particles would not move away before the object arrives. That's why they would hit it and form a shock wave. This is why subsonic aerodynamics will always outperform supersonic aerodynamics. When exceeding the speed of sound, the smooth and continuous flow is disrupted, resulting in the appearance of shock waves. An example with which we can understand this is if we analyze the glide ratio. This magnitude indicates an object's flight efficiency, representing the distance traveled forward per meter of descent. The space shuttle had a glide ratio of 2 at supersonic speed and 4.5 at subsonic speed. That is, at subsonic speed, it flies more than twice as much as at supersonic speed. And to compare two aircraft that competed for the same air routes, the glide ratio of the Concorde at cruising speed was 7, while that of the Boeing 747 was 17. All projects about a supersonic passenger plane independently arrived at the same conclusion. And that is, the design had to be a delta wing. For supersonic flight, it is essential to have wings with a backward sweep angle and a delta wing configuration. It would also help in low-speed subsonic flight for landing and takeoff. The US promptly withdrew from the program and canceled it due to various economic and climatic factors. But to this day, many people say that they were simply very behind with the technology and that they were too late. So they decided to oppose these projects, to such an extent that New York City banned the operation of the Concorde in 1976. This was seen by the United Kingdom and France as a real nonsense, and they complained, so a year later this sanction was lifted. It's important to understand that around this time, a multitude of movements against supersonic flight appeared, to such an extent that flights above the speed of sound were eventually banned. Over Sweden, Norway, the Netherlands, West Germany, Switzerland, Ireland, Canada, and the United States, many other countries joined later. Be aware that the ban from these countries was not on the Concorde itself, but on its supersonic flights. Since any object that moves faster than the speed of sound will generate a roar known as sonic boom, like the firing of a firearm. It sounds that way because shock waves are generated in the process, and as we have said, when a plane flies supersonic, shock waves are also generated. That's why the sound is quite similar. Well, this made the sonic boom audible even if the plane was flying at 10 or 15 kilometers of altitude. Now we talk about that, but I remind you that what New York City banned was the Concorde itself, not supersonic flight. The problem this plane had was that as its aerodynamics were designed for supersonic flight, for subsonic flight it was very poor and needed to take off using its 4 engines with afterburn. I'll leave you a video so you can get an idea of the sound. Okay, I think you can now understand why there were so many people against the Concorde. That said, I wish I could have experienced it. This occurs because when the plane hits the air, it compresses it suddenly, creating a concentrated wave front that travels through the air. Let's see in slow motion what happens when a shock wave passes through us. But let me first tell you that an object at the very least will always generate 2 shock waves, one at the beginning of the object and another at the end of the object. So a person is so calm and suddenly the first shock wave arrives, which is a sudden increase in pressure. Our eardrum interprets the sound as an explosion. Milliseconds later, the second shock wave arrives. In fact, your head is going to explode. But it's not that a shock wave sounds like an explosion, but that an explosion generates a shock wave, and that's why an explosion sounds like that. The 2 shock waves generated by any object are separated by a few thousandths, making it possible to confuse them as a single one. But the reality is that a plane generates several shock waves. In the year 1964, the FAA decided to carry out Operation Bongo 2, which consisted of generating 1,253 sonic booms over the city of Oklahoma over 6 months, averaging about 7 sonic booms a day. Starting at 7 in the morning, the booms were increasing in intensity over the months. At first, the inhabitants saw the experiment positively and adapted to living with it. Apparently, as the booms always occurred at the same time, there were people who even used them to know their meal time. As time passed, complaints rose significantly, forcing the test to be halted due to citizens' discomfort. In fact, 147 broken windows were reported during the first 3 months. But the sonic booms of those weeks should not have broken any glass, so there was concern that fatigue on the materials was being caused by the sonic booms. But that sudden sound occurs because the pressure changes radically. But if somehow this pressure increase could be made more progressive, we wouldn't hear that explosion sound. And since supersonic flight was banned, that has been the idea to design something that allows for progressive pressure changes. I've discussed several past projects in detail in the video you're watching. But National Aeronautics and Space Administration, in collaboration with Lockheed Martin, has been developing the plane for several years with which it intends to settle this issue, the X-59. A single-engine plane shaped like an arrow with a very elongated nose, with the aim that the nose generates several weak shock waves instead of a single, but very strong one. This project is named Quiet Supersonic Technology, because this is its only goal. National Aeronautics and Space Administration is developing a plane solely to research the sonic boom phenomenon, which is quite remarkable. Is it going to be measured in the real world? How strong is the shock wave of this aircraft? And it's going to be tested over cities to see how it affects people's lives. They've done computer and wind tunnel tests, but now it's time for real-world testing, the moment of truth. The idea is that if these trials go as expected, the restrictions on supersonic flight over land can be lifted. In a way, National Aeronautics and Space Administration could also collaborate with companies that want to make supersonic commercial airplanes to facilitate their path. Several of the Concorde's problems now have solutions. For example, current engines have much more power, which allows to dispense with the afterburner. For those who don't know what an afterburner is, it's that thing you can see throwing a flame backwards. That component causes significant noise and high consumption. On the other hand, today's aerodynamic design is much more advanced and optimized through the use of computer simulators, for example, in supersonic flight. The area rule is very important, which says that to reduce the shockwave, the growth of cross-sectional area in an airplane must be progressive, from the tip to the tail, and that's the idea of the X-59. In fact, if you look where the wings have the most area, the fuselage narrows to follow this rule to the maximum. This was known in the past, but they didn't have the current manufacturing techniques, so they couldn't apply it. Moreover, manufacturing costs will be proportionally lower since only the final prototype will need to be produced without intermediate iterations. Since we have computer simulators in the 60s, each prototype had to be tested in wind tunnels. Okay, and how is the future? How many companies are there? Until recently, only 3 major companies manufactured supersonic commercial airplanes. Aerodyne, the first of them, went bankrupt in 2021. The company planned to build 2 planes. The first, AS-2, would fly at Mach 1.4 and carry 12 passengers. The project had multiple partner changes, starting with Airbus, then switching to Lockheed Martin, and finally to Boeing. The second project was the Aerodyne AS-3, a 50-person plane that would fly at Mach 4 and have a range of 7,000 meters, which would fly at Mach 4 and have a range of 7,000 meters. But I'm sorry to tell you that 2 months after announcing this plane, the company went bankrupt. Another company is Spike Aerospace, with their Spike S-512 plane, an aircraft that could carry between 12 and 18 people and fly at Mach 1.6. The company was supposed to conduct trials with the aircraft in 2023, but there hasn't been much news about it. The third company is Boom Supersonic, and it is likely the most well-known. I previously discussed their primary project in a video, which involves developing an aircraft that can transport multiple dozen passengers. They have already built the demonstrator, a small plane that includes all their ideas for the future commercial aircraft, in such a way that if something doesn't work, they would realize it before building it and could fix it. In 2023, they have been conducting ground tests, and by 2024, they are expected to be performing flight tests. There are high hopes for this company, as they already have a demonstrator plane and many collaborators supporting them. So it is very possible that this project will go ahead. However, in recent years, a new project called Hermes has emerged. The truth is, they are doing quite well on social media, because you probably recognize this video. Their goal is to develop a hypersonic plane with a combined cycle engine. That is, operate a turbofan engine at low speeds and a ramjet engine at high Mach numbers. What's interesting is that they are also developing the engine. This company, founded in 2018, has plans for both commercial and unmanned aircraft. To fly at Mach 4 would be incredible. You could travel from Paris to New York in just 90 minutes. Do you really think that's crazy? From these projects that I've mentioned, it's possible that some data may change, because one thing is the initial idea and another very different thing is what ends up being manufactured, especially when they are in a stage of financing and they still don't have a prototype built. If suddenly a big money investor came in, but in exchange for slightly altering the project, they would probably have to accept it. Importantly, neither Boom Supersonic nor Hermes have discussed reducing the sonic boom. Currently, they are focusing on covering transoceanic routes without wasting effort or money on the whole sonic boom issue. If National Aeronautics and Space Administration's X-59 trials succeed and these 2 companies survive, they could collaborate and share technologies in the near future. Spike Aerospace claims they will reduce the sonic boom, but they have published the least information compared to the other companies mentioned. And regarding the videos they have made public, they are only renders from almost 10 years ago. The issue with supersonic flight is high fuel usage. Simply by exceeding the speed of sound, aerodynamic resistance increases greatly. Therefore, a ticket on a plane that flies at twice the speed of sound will always be more expensive than one that flies at Mach 0. Eat 8. But if these companies are able to greatly reduce flight time in exchange for a small increase in price, it is very likely that many people would opt for this option. But for now, that remains to be seen.